7, 8, 9, 10. This is Chad Barron. You're listening to My Alien Life.
My Alien Life Podcast.
Three, two, 1, 0, 0, and liftoff.
That's modern technology.
Oh, isn't it something? I love it.
Modern technology. Saw one of my friends was watching or mentioned you on YouTube and was watching
Really?
your documentary, and I did the same, and I was blown away. You built something extraordinary, and we have plenty of time to discuss that. But if you only had 20 seconds to explain what you created, how would you do that? How would you do that?
Well, I would explain it as creating the facilities and capability to explore and answer a big question: are we alone? There's your 20 seconds.
Yeah, that's a question that, excuse me, many of my listeners, they have a lot of personal experience. They have lived vicariously through other experiences from other people. They research and they try to come up with some of the same answers that you were trying to come up with, but you did it a little bit differently. You took that one step further. Where did that desire first come from? Do you remember?
Oh, multitude of sources. It was a combination of things. First off, I would have to say that I had heard this back in 1964, 65 during the Ann Arbor UFO flap or activity when Dr. J. Allen Hynek was called in to investigate the swamp, so-called, he called it swamp gas, but it was something else. And that was broadcast. There was quite a bit on WJR radio out of Detroit. That's where I lived in the winter, during the winters. And I heard one of the broadcasts, and one of them was very interesting in that this farmer and his son went out into the field and saw a craft or something that had a quilted-like surface. And they pointed to it and said, "Look at that horrible thing or that weird thing." And about the time they did that, it lifted off the ground, took off, and flew away. So, I mean, when I heard that on WJR radio, that had my curiosity fired up pretty good. That was one of the elements that really got me thinking about this.
How old were you at the time, John?
Geez, good question. Because that was in 64, 65. I was born in 51. So let's see. We'd have to do some quick math here. Let's see.
So you're 14, 15 years old.
Yeah, I wasn't that old. Yeah, exactly. I mean, it was before I was 18. I know that.
So there was a big surge in UFO reporting activity in the 70s, mid 70s, late 70s, and I know that interested you a lot. But back then in the 60s, when you heard about UFOs and UFO sightings, was it big in the news? Did you hear about it a lot? Obviously, we had Roswell in the 40s, but what was happening in the 60s?
Mostly, there were a lot of sightings around, all over the country, but Dexter and Arbor was, for whatever reason, a hot spot. There was a lot of people that were seeing these things, and they were actually seeing what would call nuts and bolts aircraft and this sort of thing. I've even met people today that live up here near where I do that actually saw them up close, and they described these things to me. And it's astounding. It's absolutely astounding because they're describing a craft with like ports or windows with beings or creatures inside that looked right out at them while they were hovering above the ground, the ship or the craft, and standing there going like, huh? We are. I mean, that's the witnesses that I know personally, and these things are a whole set of events. And over time, this has been going on for a long time. It isn't just 65, obviously, but the fact that these all coincide, and I've met people that have experienced this kind of thing up close. That says a lot. It really makes you think. Even today, even after the search, has ended in a sense. But I never give up hope that there'll be more coming from the disclosure coming from the government, from the Navy, the military, intelligence services, and so on. So I'm always looking at that angle too, especially now. That's where it seems like the real awakening will come out of. It will be from sources that are you wouldn't have thought would ever come forth.
So was science back then something in your background, something of electronics? Were you interested in electronics then?
Oh, heavens, yes. Everything to do with electricity, electronics, science itself. I was a scientist in a sense. That was me. I always had a scientific kind of curiosity and just a natural curiosity as well. But I always liked to base my search or gathering of data on good science. I believed in science. I believed that you had to take the time to evaluate what was going on, take the time to get data, do it in a logical way as well. It's just say, okay, there's something out there, you can't figure out what it is, you're looking at it, and it's a kind of a mystery, or it's causing some strange effects, or whatever. It's nice to be able to analyze it more thoroughly, get data. Like I keep saying, hard data is valuable. It's valuable in any kind of research. So for me, it was that kind of an effort, and curiosity drove the effort. And the fact that I also felt, and this is something you can't quantify in science, but felt that there was something more out there than we were normally aware of, and that was where this exploration angle came in, is that curiosity to find out. But at the same time, shall we say, balancing it with good science, electronics, instrumentation that can measure electromagnetic, electrostatic energies that can be emitted by these objects at close range, this kind of thing. This is what I really tried to lock into as a way to evaluate that, maybe record data and get some information, not so much for the public straight out, but for other researchers that were doing the research like this. Few were in this time, except maybe military or some other people, but there were, it's J.L. and Hynek and some of these folks that at first didn't believe this stuff could really be going on. These had to be swamp casts or whatever. And some of it may have been an official line, government, pull the government line, and follow that and just kind of deny this stuff so people don't panic. But
so if you were, what was the first example that you knew of where the scientific method was being used? Because I think it's super important that when you're researching, you use a scientific method, but then you also mentioned the fact that you had this desire to find data and empirical data, something that was tangible, something that you could measure. So when did that scientific method first become part of your research tools?
Well, I would have to say it actually became part of it in 73 through the 90s. So 73, 74, right in there is where I started to put together a station with real equipment, with funds that I could pull together myself, and my grandmother helped support a little bit of it as well. And I started then. I would have to say that was a firmer part of it later on in life, when I had a place to do it and maybe a little bit of funds to work with. Not a lot. It wasn't a major university effort or anything like that. It was all privately done. So that was kind of about the time that the real instrumented UFO research effort started to take place.
Prior to, let's just talk about the mid 60s and you growing up. When I was your age at that time, you're about 10 years older than I am, but back then I had, we were able to, in the 70s, order chemistry kits. You could order those electronic kits that basically had a board with springs and you jump wires and things like that. So were you into that? Were there things like that available for you to test your skills as a scientist prior to the age of 15?
Oh, sure. Now that's an interesting. I like that. I like that analogy. Actually, my grandfather had some nifty things in the basement because he used to work on automotive maintenance and repairs. So he had ignition coil testers, and electrical devices. Okay, and I I started to play around with some of that, and that's where it got interesting because I learned about the behavior of electricity. Once I got a good feel for what electricity could do, how you could harness it, control it, do cool things with it, whatever, I started to experiment a lot. I had a Lionel train set, and one of the first things I did when besides running the train and enjoying that, was to take one of the beaded chains, those little bead chains that used to hang from light bulbs. You'd
Right.
your light sockets. Okay. I took that and dragged it across the tracks, and a lot of little sparks came off, and I thought that was kind of cool. So right away, I was fascinated by electricity, just in the fact that, hey, there's something neat about this stuff. This is kind of cool. This is fun. Neat fireworks. So it wasn't long before I was experimenting with a little higher power stuff, and it wasn't all that much longer that I unplugged the train transformer, which steps the voltage down from the wall, to a safe voltage and plugged directly into the wall, of course. And about that time, that's when I blew a hole in the carpet with some steel wool and some electrical wires. So that was, my grandfather kind of scolded me for that one, but he certainly was very encouraging and supportive in the sense that I could go forward from there. So he figured it was safer to buy me one of those hand-cranked military telephone ring generators. It still puts out about 90 to 100 volts, but it's a little safer. You don't blow things up too bad with that. So he got me one of those and mounted it on a board and put a pulley and a belt on it and a big crank so I could crank that thing up and get it going, get some electricity out of it. So he was very supportive. He was wonderful. He was a tool and die maker, too. So he knew machine shop, electrical stuff, basically. But I was soon to advance very rapidly in my knowledge of electricity and ways to apply it and to do things with it. So that was a great lead-in for later years when I would actually build machines and electronic circuits and equipment. Most of the stuff I had back then when I was a kid with him wasn't even, it wasn't really, like you say, the circuit boards, the little things with the springs, and you connect things and do your circuit development that way. I didn't have that. It was all pretty much crude or handmade or military surplus or stuff like that. So kind of got my hands on the more rudimentary kind of stuff, but I learned a lot from it. So that would be a good way to describe some of my starting points with electricity, electronics, that sort of thing.
So where did the biggest first burst of knowledge come from? Where did that take you?
That's an interesting question. I don't know if it was a big burst so much as it was a ramping up. I would say more like a ramping up of knowledge just over the years as I worked with it more, and it sort of filtered in or ramped up over time. And I became more, agile, if you will, with working with electricity, electronics, electrical devices. It just grew in time, and I got very, very intimate with that kind of technology. So it wasn't that hard for me. It was like it came natural. And at one point, I could just say it just was a natural thing. I just worked with my hands, built the machines, wired them up, pretty much knew what the tunings would be, the voltages, the currents needed to run them, things like that. It just kind of came to me intuitively. I had a lot of intuitive sense of that kind of stuff. It was just sort of visionary too. I could envision a design for a piece of equipment, see it in 3D in my mind, and rotate it and look at it, and then actually build it. And I had learned from my grandfather the skills needed to build physical things, taking steel, drilling holes of proper size, threading those holes, putting screws into them to hold things into place, building framework, building equipment, bending and forming the framework, whatever had to be done. And so I was able to build almost everything from scratch. I didn't have a lot of money. There wasn't a lot of money in our household. So a lot of this had to be done by hand, carefully, piece by piece, over, many years. So that's how kind of that all came about, but it was over a long period of time, too.
But, what you're describing to me is basically electrical engineering, which is filled with mathematics. It's filled with years and years of education, and not only just education, but on-the-job training. So was there any time in your life early on that you experienced some on-the-job training? Did you look for work in the field?
No, not at all. No,
Wow.
I was just, I had really little or no connection with it. I just, part-time, I worked at a camera shop, cleaning and doing maintenance, dusting cameras, stocking shelves. No, I had no formal training whatsoever.
So what was the first big piece of equipment that you added to your collection or soon-to-be collection that started the search for extraterrestrial intelligence before it was before SETI was actually a word?
Well, yeah, that's a good question. I got to really think about that. I think the first piece of equipment may have been some of the vertical marker beacon system. That was a unit I built up from ground up. It was a 150-watt high-power ULF amplifier transmitter, whatever you want to call it, with a extremely high voltage output to the antenna. And the device was tone encoded. It had a set of binary tones you could power. A friend of mine helped me build that. I had him build a binary program controller that did that. But the rest of it I built myself, the high voltage part, the tune circuits and all that. And that was a unit that was about 64 inches. I still have that, actually. It still works. 64 inches high, 19-inch relay rack size, about 20 inches deep, and full of transformers, circuits, and controls, and lights, and indicators, and an input circuit so you could feed audio into it. You could even drive it with an audio signal. So that was what I would say that's probably pretty close to one of the devices that I started out with, one of the larger pieces of equipment.
Very interesting. So immediately you were actually trying to send a signal to space.
Right. At least ionospheric. At least give ionospheric propagation happening. Transmit the high voltage frequencies into the ionosphere to create a field or create a signal so that something could detect it.
And that initially started in your bedroom and began to expand?
That's right. Yeah, it started in the bedroom, yes, and then it just got bigger and bigger and bigger. Then there were soon like 7-foot high racks full of equipment, relay racks, full of all kinds of switching gear and power equipment and circuits and controllers and go on and on and on. Power supplies. Well, I had to have a lot of power supplies to run it all, so it got pretty big really fast. And there was also a military radar console that became available. It was really cool, and I still have that too. And we moved that into the house. It was about 500 pounds. We had to get it through a door, so we had to take the door off the hinges and everything and take some of the casing off to get it in. It just barely fit through a 32-inch door because it was that big. And put that in there, and I started working on that, and that was quite a project. But I was able for a while to get the radar transmitter up and running and the radar scope so it could watch for aircraft and stuff. It was kind of neat. It worked for a while. It was good for about, I think, 7 or 8 years before any major failure or any problems with it.
What about the procurement of power at that time? I mean, did you have just normal power coming into the house, or was there something extra that you had to add?
Well, later we did. Oh, yeah, for the bigger complex we did. But starting out, it was like a 60-amp service and a rural electrical distribution grid. So that was plenty at the time. That was enough to run all the equipment and the lights in the house. And my grandparents didn't have even a microwave for forever. So it was like all the power was pretty much going into that equipment. Probably about, I would say, I don't know, back then I would say maybe 1,500 to 2,500 watts of power to run most of it. It wasn't real. Well, it's vacuum tube equipment. We had a little bit of that, but most of it was going into solid state at that time. So there wasn't a lot of huge banks of vacuum tubes heating the house for us in the winter or anything like that. But
is it multi-directional transmitting or is it unidirectional? Do you know what I'm saying?
Absolutely.
Okay, so what did that look like, and what were you aiming for?
Well, it was more or less between unidirectional and cardioid, kind of like if you're familiar with cardioid patterns with microphones. It was designed to transmit pretty much vertically upward. It wasn't really designed to go out to disperse horizontally like a standard radio transmitter, AM or FM transmitter. It was designed to transmit to the ionosphere or beyond. So it was set up in such a way, and the frequencies, the angle of the antenna elements and everything were tuned or designed to transmit as much vertically as possible, straight up. You get a ground wave. You do get a ground wave, reflective ground wave, where you can pick it up like nearby in the earth and then metal objects nearby, and even in the lake down by about 400, 500 feet away. You could hear the signal, hear the music, or hear the signal going out a little bit in the background. But that's your counter-terrain field. That's your reverse field that you get. When you push energy out, you have an opposite energy field produced in the earth. That's how, of course, transmitters work. So you do get a reverse field, but you also get the signal going upward as well.
So if you're signaling upward, is that kind of transmission infinite? I mean, obviously it degrades, but
Sure.
it is infinite. And if there's a tool out there that could pick up such a small signal, it could travel for how far?
That's the best question of all, really. You know, my best hopes, and I didn't have all the mathematics to back it all up, but my best hopes was that it would get through the Earth's ionosphere, and once into space, it would travel for a great distance. But then you do have noise, you have background noise, you have radiation, you have interference, you have other factors, and just plain old square of the distance and dissipation of the signal. But the hopes was that it would go, well past the moon and on further out, especially with the larger transmitter, the 1,000-watt transmitter, which is more concentrated. But with the earlier transmitter, the idea there was more, okay, let's try to get a close-range signal that goes, 150, maybe 200 miles straight up into the ionosphere. And if there are any UFOs or objects that are mechanical or powered devices that are physical with occupants, or if they're probes, then maybe they could pick up that signal and we could attract them closer to take our measurements.
Interesting. So if it is possible to let me ask it a different way. Is it possible to determine the distance that signal would travel? And if so, what type of scientists could determine that, and what would that look like?
That's a tough question. I don't even know the answer to that without a supercomputer or some very good mathematicians and radio engineers. They would probably say it wouldn't go that far because of atmospheric interference, or because it's a low frequency, or because this or that. I can't answer that for sure. I went more on the hopes there.
So initially, you started building the apparatus, and It filled the bedroom, gradually moved. I think I saw a picture with your grandparents in the living room. Is that accurate?
Yes, that's what you saw there was real. That was a real photograph taken by a Detroit Free Press photographer, or working for the Free Press at the time. Yeah, that's a classic photo. It's a gem. And then I took the same photo. I duplicated the photo myself, since I was into photography around that same time. So I also took a photo just like it when they were out there sitting, and I set the timer on the camera, set the scene up, went over into it, and became part of the scene, and created the same photo because I loved that photo. It was great.
Yeah,
and now it's available.
That's an incredible photo, and they're just kind of sitting there, and and that's for one brief moment in time, and this is something that went on for a very, very long time. So to me, I'm looking at those two people thinking they're probably two of the most wonderful people and the most patient people that you could know, and I would love to have met them.
Oh, they were wonderful. Yes. You described them right there to a T. They were so supportive. That's the thing. My grandmother was very supportive, very, very warm, very understanding. And she believed there was stuff out there. There was more to, life than just what we see here. That there was a very real possibility that there was intelligences existing out there somewhere in space. And my grandfather was more of a, well, yeah, those crazy guys, they won't let us land on the moon if they know what we're up to. That was he said that once. He says, oh, they're going to chase them off the moon. He said that, and I said, boy, that's pretty wild. And but my grandfather was a very realistic, down-to-earth, nothing-but kind of person. So I had that kind of influence from him, because he, when he set up to do machine shop work, or work making tool and die fittings and all this stuff, he would use calipers. You'd measure to the thousandth of an inch. You'd machine it. You'd check it. You'd do this. Get it right. And he taught me all that. But he also had that precision thinking. Okay, this has to come in within this tolerance for it to work. And that was how he saw it. And that's what was solid mechanical, logical background that he had. And where my grandmother was maybe a little more open to the possibility of what might be out there, and just more etheric in nature, if you will. So it makes for a very interesting combination, but great grandparents to be raised by. Just absolutely perfect. The combination is a yin and yang. It's perfect.
Yeah. I could tell that from that photo. I mean, that's what first really grabbed my attention. I thought, wow. I actually had a neighbor growing up who was really into ham radio, and by the time he was 12, their whole entryway and part of the kitchen was filled with his electronics. And I used to get to go over there from time to time, and I was totally fascinated. One of the things that I never found out, and I'm going to ask you the question because this pertains to you, the first few years you were doing this, where did this raw material come from? I mean, where were you getting these supplies that you were putting together to create this most amazing electronic device?
Oh, I love that question. I just love that question because it's the most practical question of all the time. A lot of it was materials that you could buy locally, like when when I built the cabinets and those things, put everything in the racks, the equipment bays, and stuff like that. That was what was called hot rolled iron, hot rolled angle iron. It's something you can buy. It's 1.5 inches, 2 inch, whatever you want to get it in. You can get it in 20-foot bars, and then we would cut it and drill it and thread it and put it together and make the cabinets. The sides of the cabinets would be either masonite or tempered hardboard. Which is masonite basically, but it's tempered. It's really strong. And then we'd drill and bolt those on. They'd all be screwed on. It'd take a month or two to build some of these things. So a lot of it was built from raw materials. The electronic components came from everything from military surplus equipment to telephone communications toss-offs. I would rummage through trash bins at the telephone company looking for anything I could find. I didn't have a lot of money. I was poor. By today's standards, I was in poverty. So we didn't have a lot of money. We simply didn't. We had a home, yeah, but we didn't have a lot of money to go out and spend. So, and it's, it's one of those things you have to be creative. You have to look for sources that are all around you. That source is always around you. You just got to see it, because the things that people throw out, the things that are scraps or this or that, or even just surplus. Military surplus is fantastic. It's probably some of the best quality stuff you can get your hands on. And it's the pennies on the dollar, cost-wise. So that made it feasible. So by buying a lot of that, by scrounging what I could, going to the electric companies, the utility companies, I used to buy transformers and wire and meter parts and things from the utility companies. They were really friends of mine. They were wonderful.
Wow.
They loved it because they knew they could get a little more, sell more electricity to me. I guess that worked out well.
They sold a lot. I imagine they sold a lot of electricity to your family. I can't even believe that. Since we're talking about decades and decades prior to Craigslist, what resources were out there at the time? Were there trade magazines and things like that you could look at to find material?
Oh yes, that's exactly what there was. There was no internet. There was none of that. So you got mail order catalogs from Fair Radio Sales in Lima, Ohio. They were a huge warehouse. They would buy up gazillions of tons of this stuff, and they would sell it out piece by piece. And back in those days, it seemed like it was affordable. Today, you look at their catalog, and it's getting up there pretty pricey. But back in the day, it seemed like, something I could do, and I did. So on what little bit of income I had, what little money my grandparents sent my way, I was able to purchase a lot of components, a lot of parts, and a lot of the stuff was down to individual parts, capacitors, resistors, diodes, and wiring all that on the circuit boards myself. So that made the cost, that eliminates a lot of cost, okay? That makes it affordable. Even if it is large scale, it makes it affordable because you can build your own cabinets, you build everything, and that brings the cost way down. But over many years, it looks like a lot. You do that for 15 or 20 years, you've got a lot of equipment by the time you're done.
Yeah, and being a builder myself, I can appreciate that. And the one thing that I know when I'm looking for a good deal, especially if maybe I'm going to build a guitar, is that I'm always looking. So, obviously I'd rather be building, but there's so much looking that is required to acquire. And did you ever feel at any time that you're spending too much time looking and not getting enough raw material for you to create?
Not really. I was always pretty good looker.
You're a good looker.
Yeah. Yeah, back in those days. But anyway, I could find things that were more obscure or just what I was looking for, kind of things. I was free. I guess I lucked out really well on that. I was a good resource person. In today's world, they're useful because they can find those hard to find parts or hard to find components or whatever and source them. And that's, I can still do that to this day. I have not lost that skill. But with the internet, my gosh, that's heaven. That's dream come true there.
Yeah.
Because now I can go anywhere in the world and find whatever I need.
So when you're looking at the internet now, do you still love that old stuff, the old parts or
sure.
tubes and things like that, or are you into the newer as well? Newer electronics?
Pretty much all of it, although I'm into the solid state. All my studio gear now is all beautiful new solid state equipment. I've got a 20-channel mixer here, state of the art. I've got a dual CD player mixer. I've got a couple of racks, almost floor to ceiling. They're 6 foot tall, full of audio switching gear and program gear, as well as matrix mixers and oscilloscopes for the channels to monitor the audio and everything. So, if you could see the studio here now, it's pretty nice. It's not hurting.
I think one of the things that you don't really get an appreciation of. I mean, it's the creation was vast in itself, but you're talking about building these cabinets. Inside these cabinets, they're full of electronics. You don't get to see that.
Sure.
And, there's miles and miles of wire and everything you could possibly imagine electronic in there. How do you manage a project like that from the macro to the micro?
Oh, it's pretty easy. It's a matter of doing everything in the proper order, proper sequence, wiring everything from building the cabinet to connecting the power to building the circuit boards that will operate the machine to the readouts that will display the information you want displayed. It's a step-by-step sequence, and you do it in that proper order, and everything comes together, and you test it out. If it doesn't work, you go back and you find the problem, and you fix it. And then you get it up and running. That was my attitude. If it blew out and there's some sparks, I'd go back and I'd find out what blew out and why. And then I would make it work. One way or the other, I'd get that sucker working.
What was that first broadcast like?
Oh, I would say it was pretty low-key. It wasn't like I wasn't setting the world on fire. Nothing like that. It was a matter of once I got the transmitter powered up and everything indicated it was green for go, I put a test signal into it, and the test signal came out. It came out clean. It was there on the antenna beautifully, and the receiver picked it up great. So I thought, okay, we're making excellent progress here. And the next step was to come up with the encoder and get that fully operational. We got the encoder operational, and that started transmitting binary tone sequences. And there wasn't too many months after that. I think it was like 4 or 5 months. We started broadcasting analog signals in the form of Songs of the Humpback Whale, and then came music. Music was like the next natural step in the progression. So we started beaming music out into the ionosphere.
Did you have the capability of receiving signals to see if your signal was being heard?
Yeah, yes, up to a certain distance, we could pick it up the side of the antenna, or like I say, down by the lake. We could pick it up around the antenna in the local area, but the strongest signal would be going vertically. It's just the way it was designed. It would go vertically. And I brought a friend of mine that I knew brought in an aerial bucket. So we went way up in the air above the antenna, and the signal was pretty screaming up there. It was really loud. So I knew it was going where it should be in the direction it should be overall. The strength was much better going straight up. So I could at least confirm that. I wasn't up in a plane or up in a satellite or, a space station to check it, but at least I knew from that if the signal was propagating vertically beautifully. It was really strong.
You talked about the evolution of what you were broadcasting, but later on you started broadcasting music. In addition to music, did you ever broadcast your own voice?
Oh, absolutely. I actually spoke about the music on the air when we finally got up a little bit the next step. And we had the program board and mixer, everything, the turntables. Most of us turntables and cassettes back then, before the CDs came in. And I had a microphone, a couple mics actually. I had one right at the board where I could announce the pieces and do the programming and describe the music. Yes.
So what was your music library like? What did that look like? And what was a usual broadcast session? How long?
First we started out with about a 1 hour broadcast because we're just getting up and going. We might have had, 60 to 100 different vinyl LPs. As I recall, we started with vinyl, and then we moved into cassette, and then we added more vinyl and more cassettes, and it wasn't all that many years later. We had, 1,000 cassettes and 1,200 vinyl records, and oh my gosh, it's getting bigger. And so the variety of music expanded dramatically. Like any radio station archive, we started to broadcast lots of interesting music, jazz, electronic music, atmospheric music, if you will, African music, gamelan music, just about anything that was unique and unusual. Not so much hardly any commercial pop music per se. Tried to stay away from that because, well, I already knew there's enough stations broadcasting that anyway. So I thought, let's go with something that's really interesting, that has some depth to it, that the musicians are playing their heart out, they're doing something special. There's more soul to it. So I went with the idea of soul, with something with some value, something more than just commercialism. So I always tried to do that, something cultural, creative, innovative.
Did this ever interfere with local radio or TV stations? And what about licensing? Was that required?
No, not when we were doing it, because we didn't operate on any of the standard frequencies. We operated on a frequency that was considered unregulated. It was below the frequency of any AM, FM, or television stations. So it was ULF, ultra low frequency. Of course, the equipment had to be 10 times the size and massive to do it, but I figured that was the best way to go. That way it wouldn't be causing any problems for any other stations or anybody else, and wouldn't have to go through endless paperwork and hoops and loops and never get there. Couldn't afford it. Couldn't possibly afford it. So I took the chance. I went with it. Pirate radio, if you will, but not interfering with anyone. Not even probably picked up by anyone on our side.
So for the novice out there, explain the ultra low frequency and what that means and how that compares to other frequency bands like HF, MF, VHF.
Oh, right. ULF is from like 40 hertz all the way up to maybe 24 kilohertz, and that's just beginning to approach into the what you would call long wave or AM range, just barely, not even enough to interfere with anything. So it was very long wave, extremely big. To even get an eighth of the wavelength, you had to have a huge antenna. Everything had to be big and a lot of power and voltage. The key to that was getting the voltage high enough to ionize, to connect with the air, to get the impedance match. Because you had to, at those lower frequencies, you had to have high voltage to couple the atmosphere, the oxygen or the air, and ionize it to get the transmission to happen. So that was part of the key. That was a kind of the secret sauce to make it work.
Interesting. So, after expanding into from the bedroom to the living room, you decided you're going to build an addition to the house. How big was that? How long did it take, and what was that process like?
That was quite the process. It was a big undertaking. I can describe some wonderful and interesting and even boring moments, but I'll pick out the best. That addition, my grandfather had passed, and my grandmother and I decided to pool our resources, our savings, our money, everything we pretty much had, and build an addition so that we could put the equipment into its own space and yet keep it near home, keep it, close where it could work with it. So what we did, I drew up the plans, I pulled the resources together, again, sourcing materials and special flooring and everything. I mean, this thing was designed to be a transmitter studio, lab, whatever you want to call it, research facility. The room was built over a period of about 2 years, I think 2.5 years. It took to complete it, to get it enclosed and everything installed, get the flooring in. The room was built with no floors in the center. It was just the basement cement, and then 18 feet up was the ceiling. And in between were modular flooring, steel flooring beams, steel supports. The whole thing looked like a space station itself because everything was modular. It was designed to be installed and fitted into the space and actually be adjustable height-wise between the upper and lower floors. So I had to source all this material. I had to draw up the design so all this stuff would fit and work. And the room was, that was a big room. That thing was like 60 feet long, by 40 feet wide, and 2 stories high almost. It was like a 2-story house, 2-story building, half underground, half above ground, and coming straight off of the dining room, right off the one side of the dining room toward the west. And it was a nice big space. perfect for what I had to do. So it took about 2.5 years to get it completely done and get the floor in, get the equipment moving in, all that kind of stuff. So it was a big undertaking. I remember many a day when they were working on scaffolding in there, and there was plastic sheets hanging over the wall of the dining room. We were in the kitchen making food to eat, and they'd be in there working, and they'd be moving those huge scaffolds, and you could hear them screech across the floor. Be all this racket coming into the house from this huge room. So it was quite a massive undertaking. It was fun. I loved it, but with my poor grandma, she said, "Boy, is it ever going to get done?" I said, "Well, it looks like it's making progress."
So did you create something in that infrastructure to make things easier to move around? Did you have any lifts or anything in the ceiling, or how did you get things in and out of the new addition?
Yeah. Oh, we did. We had to. There were special beams installed, big steel beams and supports in the ceiling with hoists, so we could move these 400 and 500-pound transformers into the room, because they had to go on the first level, down at the ground level, way down below. So we had to have hoists in there to lift these things in. These transformers were purchased from the utility companies. They were big distribution transformers. So we had to have like 2 of those huge ones in there, and they're 50 kVA, and they're heavy. So we used hoists. We had hoists in there. We could raise it up bring it in to the doorway, and it's hoisted right off the deck there and lower it down in. So it was quite a neat operation.
At its greatest capacity, what did you require from the grid?
Probably we pushed it. We probably pushed 60 amps a few times, but then when that room was built, we had a 200 amp service brought in. We had a lot more power brought in, so we had plenty of power. That was never an issue. As long as we could afford the electricity, we had plenty of power. That was not a problem. We had 2 huge 100 amp circuits.
Wow. So, at that time, was this an operation you guys could afford at that time? Just to, could you afford the power bill? What was the income, and how did you keep going for so long?
Well, a lot of it was just money that was pension money and money I earned on the side. And luckily, we had, between the 2 of us, enough savings that we could still keep it going. And when my grandmother passed away, it was pretty much on my shoulders. And that's when I got into trading stocks and commodities and doing things like that to make money. And when I got doing that, I made a fair amount of money a few times. Quite nice amounts. Nothing amazing, but, 100% return in a couple months and some stuff. And that really helped. And I did that for a while. I had some ups and downs. Later on, I had less than great results, but starting out, it was terrific. Bought a lot of those penny stocks, those darn things for 10 cents a share. Buy 4,000 shares, and all of a sudden it shoots up to 70 cents a share, and you cash it out. It's a great return.
So at that time, there was no online trading. So how did that work? Did you have to go through a broker?
Yeah, I went to a discount broker and made my own trades. And I used a system, I'm trying to DTL or something. I'm trying to remember the name of it. It's out in New York. And it was a special terminal and a satellite dish. And a very special, heavy receiver. And this thing all plugged in together with a Cume data terminal. And this had a keyboard and a screen, like a computer today. I still have that crazy thing. That thing connected me with Wall Street and with the markets. I could trade instantly. Day trade my butt off if I wanted to, which of course can be dangerous. But you had this automatic alerts on there and everything. It would sound a little signal, let you know if the stock hit your price, and you could sell or buy or whatever. And that crazy thing, that was a great tool. And that was before the internet, yes. It was before the internet. It actually was broadcast from the top of one of the World Trade Centers in New York, one of the links.
So was there a prepaid prescription involved? How did money change hands?
Yeah, it was the actual service was a subscription. I'm trying to remember. It was like $65 or $70 a month back in the day, which wasn't that much. Cable's that much today and more. Yeah, geez. And this thing was like phenomenal. I mean, you didn't get TV on it. Couldn't watch your favorite shows on it. It was nothing like that. But the fact that you could trade with it was a killer tool. I mean, it would just put you right in time with the markets. And you had to have that. You had to know second per second what was happening. If you're day trading, you got to know that stuff. So that helped. You know, that was key ingredient to making some of those funds to keep the project running. So I did that for quite a few years, and did okay. And then I ended up doing some other things too. I rented a couple of rooms out in the house to boarders, people that would pay rent. So that brought in some money. So that's how I managed to keep it going. As long as I could do that, I had a way to operate.
So when did the project start to wind down?
Boy, I think it was about 94, 5, or 6. I'm trying to remember. It was kind of a slow wind down because I had to move. It got so expensive living. See, the property was on the lake, and lakefront property is taxed very heavily in Michigan, so it's kind of rather expensive. And there was like 400 feet on that lake, an intermediate lake, and it was just getting ridiculous. So I realized I had to sell the house, move everything, and wind it down. So that's what I did. So I think that was I'm trying to remember, it's good, 22 years ago, I think. I have to look. I actually have records of that stuff, but I don't remember as well, as clearly as I should on that. But just to say it was at least 20 years ago. But
for what you had at the time, it would have been impossible, I think, to move. Is that what you were thinking? I mean, that what a huge project that would have been to move that whole operation.
It was. I moved everything I could. I moved all the big machines, all the equipment, the transformers, everything to the new location to where we live now. And it's all still in storage. I haven't been able to rebuild it because the cost now to build an addition or to do that is so gargantuan, so enormous that I don't have that kind of money. I mean, so I've got to do it piecemeal again, kind of rebuild and see the rebirth of something over time again. I got to go through that time cycle to build it up. But I'm not really expecting to be broadcasting to space much or anything like that. I'm thinking more like podcasts or doing something cool and offering creative music from around the world and stuff like that on podcasts, which are more practical today, far more practical. And that would be something people here could enjoy. So I've been looking at that angle. It's something that's on the table.
Not that you are going to go this direction, but would current technology allow you to do something smaller and cheaper? Is there an alternative out there?
Oh, you mean as far as transmitting signals?
Exactly,
in space?
yeah.
Yeah, there are transmitters, microwave, high-gain transmitters that are available for space communications and stuff. They are still pretty expensive if you're getting reliable, good equipment. It does still cost quite a bit. And you still have to have certain, cost factors you have to figure, like power to run it and all that kind of stuff. But yes, it actually, in a way, it would be cheaper. It would be less expensive, but it would still take, a good dedicated effort. It's not impossible, but it's a matter of funding. It's always that. It seems to always be that.
There's a great video on YouTube where you're giving somebody a tour. I think it's a neighbor, a tour of your a home and equipment. And one thing that struck me was the kind of project that you had and working with the equipment that you had. There's got to be a certain amount of risk involved and danger. Have any close calls that you can remember?
Not really.
Wow.
I was very cautious and always explain to people the cautions they have to take and procedures when they go into that section of the laboratory, and never had any problems at all, none.
And a great respect for electricity.
Oh, yes. Yeah, you got to respect it because it can nip you pretty bad. It can get you. Electricity's a funny thing. It's a mysterious force. It's like magnetism. It, everybody's played with it. Everybody knows what it is, but try to explain exactly what it is, and it gets a little tough. But you know for sure what it will do and won't do. Basically, you know it will get if you put your fingers on that wire and you're grounded, you're going to get a shock or worse.
When you were working on that project, did you ever have any side projects that led you into developing some sort of other technology or interesting projects?
Oh, sure. I mean, there were some really unusual curiosities that came about during all of that. Some of the more interesting things were more like Tesla was experimenting with when he was doing all his wild experiments, where you could transmit energy through the air, and you could, like, I'd walk around the room with a fluorescent tube in my hands, and it would glow. It just flashed real bright because of all the energy and the radiation or electromagnetic energy, electrostatic. And, you know, it's a neat effect. But it didn't necessarily lead to development of any new technologies, but there was some interesting things I discovered along the way where certain paramagnetic fields or fields that are set up and resonate at particular frequencies in reverse phase create a strange, like almost a numbness in your hands. It's really unusual.
Wow.
Yeah, that was one of the weirdest effects. And I said to a friend of mine who was there when we'd been friends since we were kids. I said, well, feel this, check this out. I'm feeling like there's something funny going on here. What do you feel? So he put his hand inside this, what's it called? It's a current measuring coil. It was used for measuring the amount of power going through the cables to those big transformers with varying frequency. Of course, you're operating an audio frequency here with high power. It's going through two reverse phase coils inside that current transformer. And when he reached in there and felt it, he said it's kind of warm, but you know what? It's kind of like I can feel like a tingling or something. I said, that's interesting. That's exactly what I thought I felt, too. So I had confirmation from a friend that that's what he felt. I thought, So there's something interesting there that I haven't forgot about. I never pursued it, but I know how to do it again or duplicate the effect. So I'll have to look into that someday when I've got some spare time and some extra funds.
Interesting. And you mentioned Tesla. Did you ever study any of his experiments or read into him?
Yes. What was ironic is after I built all that, I started to read a lot of the books and write-ups about his work and things, and found it truly fascinating because he was a great innovator. He had this vision. He had these, kind of like I did in a sense, I guess, in a different way, but he had that vision. He could see things, he'd come up with things, kind of like, okay, where'd this knowledge come from? You know, it's just sort of, I can do this, I can see it, I can build it. And he was coming up with things. Westinghouse loved him because he came up with polyphase electricity circuits, you know, power transformers and so on that today we use every day to distribute power all over the country. Polyphase, three-phase electricity. I mean, it's like, yeah, this is brilliant. You know, it's totally logical, but he saw it, he figured it out, and they loved it. They didn't really buy his patents. He should have been paid better, but they basically adapted his technology.
So, you know, there's a lot of mystery surrounding Tesla and his creations, and many people wonder where he got his inspiration and his talent. Do you think that comes from the same place?
Very possibly. I think there's like a matrix. I think if you want to call it that, or vast storage of knowledge in, I don't like to say ether, but in space and time. There's some kind of a matrix or a place where knowledge is. And some people, some beings are able to maybe tap this resource or draw from it. Visionaries, you would call them visionaries, whatever, you know, they see things, they are given this vision or this insight. They're able to pick it up, they're able to translate that vibration, that information, that whatever it is, that source, that matrix, they're able to tap into it. Ed Dames, who worked as a military remote viewer, he was able to much training and tuning in, he was able to tap into resources that are uncanny. He was able to see technology in the future and see places you could not see with satellites or anything, as far as ground-based installations or underground installations. Things like this, things on other planets like Mars and stuff. I mean, there was just some really wild stuff there. I would stay up nights and listen to Art Bell when he would interview this guy. I mean, this guy was up there. And he was in the military's remote viewing program, so and very, very knowledgeable, very, very disciplined. Fascinating person.
Yeah, I've done a couple podcasts about remote viewing and like with Lynn Buchanan and so we've got to look into that, and it's pretty amazing. And I have a couple of friends out there who are actual practicers of that and trying to perfect that. And so yeah, there's people out there who are trainers in remote viewing. So I think that's it was a good topic when we did podcasts on it, but it's something that I've gotten into and just to read about. It's
Sure.
interesting. So what projects do you think you would like to accomplish in the future? Anything big coming up, or any wish lists that you have or bucket lists you want to fill?
Yeah, sort of. One of the things I'd love to be able to see developed, whether it's by me or a consortium of creative people and investors, would be a source of energy that would be basically clean, a source of power to run things, to do things, solar is a good example. I mean, I would say solar doesn't work, it does, wind, so forth. But I'm thinking of something that would extract energy from the ether, extract energy from, well, some people call it the vacuum, but there may be other ways to do it, and I would like to see that come to fruition. I'd like to see this happen. Because I know there's a lot of people out there today claim to have it and all this stuff. I have yet to see one single device that actually does this. I mean, they all talk about it. They all make a big hoop-de-doo about it. And some just keep trying. Some are just honest-to-goodness inventors that are trying to figure this out. And I believe there's a way to do it, but it's going to be pretty tough. But I also think that there's Rossi and his ECAT and some of those other guys have come up with, you could say it's a modernized version of cold fusion. That's a really interesting prospect. Now, the term cold fusion isn't really accurate. It's kind of like, it's just a good catch-all name for it, but it's really more complex than that. So it's lattice-assisted nuclear reactions that inside of spaces in metal. It's a whole process. There's a whole process involved, but once you get that process going, the reaction going, it produces enormous amounts of power, like fusion, but it doesn't produce radiation. It can do damage, and it doesn't leave radioactive byproducts. And the power is enormous, and it lasts for a lot longer than almost anything we got now. So there's research going on in this field. I've been following it for years, 10, 15 years now. And it's amazing what they're making breakthroughs at. You just never hear about it. But it's getting closer to being a commercial product. Probably in the next 20 years, we'll see things powered cars. Cars can be powered by this because you don't need the shielding in the nuclear reactor needs. So it's lighter, smaller, very compact, extremely high density energy.
I think it's a phenomenal that there's people out there who can actually harness not only the power of electricity, but in touch with the power of the mind, and it's remarkable that you were able to do what you've done, and I really look forward to seeing what you're going to do next. And I'd love it if you could keep us in the loop, and if something big pops up, we can hear from you and hear from you again, because I'm sure millions of people are going to watch the documentary, which is now available on Netflix. And where else can they find you online?
Oh, you could find some of my earlier work on projectstrat.com. That's PROJECT, Project Strat, STRAT.com. It's one word, Project Strat, like stratosphere. extraterrestrials.com.
Yeah, so
That's older.
a lot of stuff
That's
on
older.
the website.
Right. That's a little older information, but there's also JWTCA, which was some a broadcast I did, and a little bit about the Netflix thing being first seen at Sundance. So there's a little there as well. But I'm hoping to get another website, get my website rebuilt and get it up to speed here. I've been lax in taking care of that. So, but there is a lot of great photos on there. There are tons of photos on the Gateway page, which I think I sent you a link to.
Yes.
Yeah, and that would be one to share with people. I could get to check it out a little bit and see some of the photos of the lab. And of course, I can be contacted through that site by email.
Yeah, and so check out John Shepard. First, check him out on Netflix, and tell him the name of the documentary, John.
The name is John Was Trying to Contact Aliens.
Yeah, it's good stuff. Glad I stumbled upon that. Nice to have friends in high places that they can turn me on to new and exciting entertainment, and I was so flattered that you're able to speak with me tonight, and it was a great opportunity for me to find out what really happened and a little bit more than I knew before, because honestly, you've had a remarkable career and a remarkable life, and very inspiring, and I want to thank you very much, and I hope to hear from you soon.
Oh, you're absolutely welcome, and I will be keeping you informed. I've got your email and contact information here, and if anything comes up, I will pass it along.
John Shepard, have a good evening and take care, sir.
Thank you so much. I've really enjoyed this interview. Thank you.